Hi and Assalamu alaikum. This is Dr. Kamran from Faculty Pharmacy UITM. Today I will be presenting one of my research finding, that is development of a novel post-distillation method for recovery and purification of essential oil and GCMS validation. This work was actually collaborative work from the Gulli University, Medical University, China, and the student work in my laboratory in Malaysia, UITM. So we start with the introduction, as we all isolate the essential oil by using Clevenger apparatus, the method used distillation method. But the big problem is that the after distillation, we generally obtains most of the time water emulsion, and that oil entrapped into the distillate, and after that the recovery of oil is quite challenging and difficult. That lead to poor recovery and not good quality of essential oil. So this kind of problem always faces by researcher everywhere in the lab. So this is the see here we can see the oil which was distillate oil get entrapped in the distillate, so that formed the emulsion. This picture was taken by in from my own research work. So this method is not suitable to separate, and that lead to reduced quality and quantity as well. So we tried to resolve this issue in my lab with the student of Goli University, Medical University, China. And we started by taking 350 gram of fresh garlic. We took actually allium sativum, fresh garlic bulb, 350 gram. Then we added 600 ml of distilled water. We started hydro distillation by using Clevenger at uh, at 100 degree for 3 hours. So after this, we see the here we reported this kind of emulsion formed. So after this, we just took this and placed into the separating funnel and treated with the hexane, and three times treatment was done. After this, we collected the hexane fraction, and then we dried with the sodium sulfate, and then the solvent, hexane solvent removed. After that, we got the purified oil. Here we see the purified oil, which is also validated by GCMS method. So this method works very nice, and we isolate the even though this oil was entrapped by in the distilled solution, but after this process of hexane treatment, we purified this and we got this essential oil. So here we check this results, how about the quality of oil, whether this is good or not. So we recovered, we find recovery was quite good, 0.16% purified clear oil. GCMS confirmed this contains the organic compound, superchemical compound. So GCMS results showed so many valuable compounds, which was good in the percentage wise. Here we see the chromatogram and the compound identified. And this kind, all these compounds have the very good literature record that show antioxidant, antimicrobial, anti-inflammatory, anti-cancer, and cardioprotectives. So what is the novelty of this work? Actually, we target the post-distillation emulsion. We target the only the post-distillation emulsion, and we didn't do any modification in the simple apparatus. So we use the same apparatus. We didn't reheat and redistill. So this is the feature that we actually followed, and that lead to the improved chromatographic clarity and better productivity. So what is the advantage of over the existing method? We recover the higher oil recovery. The recovery was quite good, simple implementation. So no any other thing that instrument is quite costly, not like that. So this is a low cost, scalable, can be scalable process, and this kind of suitable for sulfur rich material like garlic and all other compounds which contain the sulfur and which form the emulsion. So key innovation method is focused on the raw material extraction. This method target the residual emulsified oil after hydrodistillation, and recovery of the good volatile oil. So it's really good for in the essential oil industry, pharmaceutical, nutraceutical, cosmetic, and natural product research. So this is my collaborator, student from Gul University. They worked in my lab, and I got this result output, and we also got copyrighted just now, a few days before at UI team. After that, we will proceed for the patent. So thank you.